Hello everyone, today in this video we'll be discussing the module wise important concepts in data mining. So whatever the notes I'm going to refer and whatever the important questions, very important questions, those are all present here. For both of them belong to my sir, Nitin sir. So I haven't done much regarding data mining because already everything the sir has done. So I'll be just referring this one and letting you know what are the key points you need to refer and what are the numericals. So numericals I'll be discussing in a separate video. In this video series I'll be just discussing the theory questions and the algorithms and everything, the diagrams and all those will be discussed in a separate video. Okay, so let's get started. And if you like this video and if you found the content which I make helpful, then make sure you hit the like button and subscribe to my channel because your support helps me make more videos like this. Okay, so let's get started. And in the module 1, as you can see, what are the important concepts is definition of data warehouse and its key features. So this PDF can be found in the description link. There you have the 6M PDFs link. If you go in that link, you will get the super important folder. In the super important folder you can find this PDF, and what notes I am referring, that can be found in the same link. And there is a folder called as 18CS 641, the subject code. Okay, data mining subject code 18CS 641. There you can find the notes which I'm going to refer. In that notes there is a folder, means there is a file called as, let me see the file's name. So this is the file. The file will be like something named as data mining and warehousing module 1 to 5 all notes something, it will be like that. Okay, so basically you can find the PDF there, and you can refer this PDF. Okay, so all the modules are here, all the important concepts, everything is here. So I'll be referring this PDF itself. Okay, so the first question was what is data warehouse and what are its key features. Okay, so basically you have to define the data warehouse. That's the first key point. And second key point is what are the key features. There are 4 key features, so you have to mention those 4 key features. Okay, so data warehousing provides an architecture and a tool for business executives to systematically organize, understand and use their data to make the strategic decision. What is a data warehouse? By the name itself you can understand it's a warehouse which has data, right? That's what the data warehouse is. It's a big warehouse where the data is stored, and it's a virtual warehouse. It's not a actual physical warehouse, but the storage systems which you use, that is actually physical, and this all data will be stored in the storage system. It's just the next level of database systems. Okay, that's all. And there is a definition here which you can use. Willem H. Inman states that our data warehouse is a subject-oriented, integrated, time-variant and non-volatile collection of data in support of management decision-making process. So if you memorize this definition, here you will get the 4 features as well, because the 4 features are mentioned here only. The first one is the subject-oriented, then integrated, time-variant, non-volatile. So we have to discuss what is the subject-oriented. Subject-oriented means, I'll say just one word regarding it. It's regarding a particular subject. Specific means it's concerned with a specific thing. It is not general warehouse. If it is regarding the businesses, it will be only for the business. If it is for the marketing, it will only be for the marketing data, and so on. It is subject oriented. Then we have integrated. Integrated means it collects the data from different sources. Time variant means it has a large scale of data, means its span is from 5 to 10 years. A very large data will be there, that's time variant. Non volatile means a data warehouse is always physically separate store of data transformed from the application data found in the operational environment. Okay, so due to the separation of data warehouse does not require transaction processing, recovery and concurrency control mechanism. Volatile means it gets affected, but the data means the data warehouse does not get affected based on the other features like the transaction processing, recovery and concurrency control. It does not get affected. Okay, that's what the main key point here is. And the data warehouse allows the knowledge workers such as managers, analysis to use the data warehouse to quickly obtain the overview of the data and make decision based on the data. So you can use it as much as you can, as much as you want. What is the, how much is the need for you, and it does not get affected by the outside features. Basically those are the 2 key points in which you have to mention regarding the non-volatile. Okay, so that was about the data warehouse and the key features. It's a very important question. Mark this as important one. Okay, then we have the differences between operational database and data warehouse. Operational database is the same thing which we studied in the database management system, and data warehouse is what we'll be studying in this semester. Okay, so what is the main difference between these two is what is asking the question. Okay, so you can find the answer here if you go to page number 4. The basic one thing I'll just let you know what I remember for the exams is the difference between the OLTP and OLAP. By the name itself you can understand OLTP is the I guess it is online transaction processing, but the main thing here is the transaction, and here it is the analytical. Okay, transaction means you, whatever you query, that answer you will get, and analytical means it will give the analysis also, means whatever the previous trends, those things you will get to know to make the decisions. To make the decision you will use this one, to make the transactions in short term you will use this one. That's the basic difference, and the rest of the things revolve around it. Okay. So that's what you need to keep in mind between the differences between OLTP and OLAP. Okay. Also we have the data warehouse architecture or the multi-tier architecture. Okay, so you can find the answer here. Multi-tier architecture, 3 tiers: bottom tier, middle tier and top tier. How you need to remember this is, firstly you will be having some databases, okay, operational databases. Then what will happen, some processing will happen. Okay, firstly there are operational databases where you have the storage data. Suppose that this is your phone, your phone data is here. Okay, then some processing will happen. Your phone is given to the manufacturer, the manufacturer will be doing some processing, it will be doing some loading and refreshing process, and when the processing is done, some data will be gathered. Okay, some data will be gathered, and where is this processing happening? That is happening in a warehouse. Okay, that processing is happening in a warehouse, so that whatever the data is gained from your phone, that will be stored in the data warehouse. Okay, also there will be data marts and the other thing, but the main thing what you need to remember is, just remember this one: operational database, some operation happened like extraction, cleaning, transform, load and refresh, and the data what was obtained, that was stored in the data warehouse. Then one person came and gave you the Rubik's cube. Okay, you are standing near the warehouse, the another friend of yours came and gave you the Rubik's cube and told you to solve it in 10 minutes. Okay, so that's what you have to mention in that way. What's the next step? Middle tier, there you will have the OLAP server, that's in the form of a Rubik's cube, and the final output what you can see in the screen is the query report or the analysis or data mining. That's how you got to remember it. Okay, and you need to make this diagram first and write the key points regarding each of these. So what are the key points regarding each of these? Here the raw data will be there, then some processing will happen, then the relevant data will be processed, and the relevant data will be stored somewhere where it is stored, big Rubik's cube known as OLAP server. Okay, and those will process the data further to give you the final output, which is the top tier output, which is in the form of analysis, graphs and pie charts and histogram and so on. Okay, so the further information can be found here. You can go through it once, you will get to know the key points. Okay, then we have the data warehouse models. So don't get confused between the architecture and the models. Architecture is what I explained, and models is something separate. Okay, so don't get confused between that. It's very important to not get confused between them. Okay, so let's have a look at what are the different type of models present in the database management, data warehousing. Okay, so what are the different models is, there are 3 types of models: enterprise warehouse, Datamart and virtual warehouse. This also you have to remember in the levels format. Enterprise means the whole company, like for example the whole Amazon, the whole company is an enterprise, right? It's a very big company. And Datamart is the small marts which is present in different countries, those are the data marts. So it is a subset of the main enterprise. Small things will be stored in the small marts, which is known as data marts. Virtual warehouse is what you will see in the screen, like right in your phone. What you will see is like these are the products available when you open the Amazon app. There you will see the offers and all those things are there. That is known as virtual warehouse. Okay, it is not present in reality, it's the virtual warehouse. It's just giving you a view, like in the previous semester, as you remember, there we have created views in the database, right? Those views, how it is created, that is created by using the means queries. Like that only we will create the views also here, that is known as virtual warehouse. Okay, like it will show in the form of screen. So those are the 3 key points what I'll remember during the exams, and you have to expand it accordingly. Okay, don't try to remember much content. If you can remember, then it is good for you, but the thing is that it's a lot of content and the time is very less. So what you got to do is remember the key points, and then you have to expand it in your own words. For that you have to go through it once, at least once you have to go through it. Okay, let's move on. The next one, which is a data cube or multidimensional data model, a very important question from exam point of view. This and the OLAP operations. So what is a data cube? So let's have a look about the data cube. Data cube is allows the data to be modeled and viewed in multiple dimensions, and it is defined by facts and dimensions. So what is data cube is the first key point. You will be writing the definition of data cube, and then you have got to define what is facts and what is dimensions. Dimensions are the perspectives or the entities with respect to which the organization wants to keep the records. So for example, all electronics is a database. In that, sales data warehouse has to keep the order of the records to store the sales. So the dimensions are time, item, branch and location. These are the dimensions, means the features. What are the facts? Facts are the numeric measures, the values. Okay, values means how many units are stored, how many amounts are budgeted. So basically you can remember these are the properties. Dimensions means the properties, like whether you are seeing the time, whether you are seeing the item, brand, or the location. Facts means what is the numeric value associated with that. In the time, how much time it was for, and what are the different items getting sold, what are the unique items present, what is the money associated with each item, what is the cost of each item when you sell, what the profit you get. Those numeric values is called as facts. Okay, so you got to define what is a dimension, what is facts. Okay, and you can give an example also here. So how this example is, there is a location Vancouver. Okay, Vancouver is a city. In that the time is given here. Okay, the time is Q1, Q2, Q3, Q4, and the item is given like 4 types of item: home entertainment, computer, phone, and security, and the values are given here. So can you tell me what are the dimensions present here? These are the dimensions: time, house, entertainment, computer, phone, and security. The facts are this one. Fine, that's what you got to define. What are the different dimensions in the fact. And data cube is, you can see the information with respect to different dimensions. You can see just in first quarter how many items were sold. You just got to add these things, right? So in one dimension you can see, and you can also see how much home entertainment was sold in the whole year. So you just got to see in this dimension, right? So that's what it's the data cube is. You can see the same data in different dimensions, and the further levels of dimension are also given. So this I have explained in more depth in the theory video. You can go through that for more information. So here is also another summarization, like 0D is called the apex and 4D is called the base. 0 dimension means all will be there, the general thing, and it will be divided into 4 things. 1D, if 2 things are considered at the same time, it is the 2D. If 3 things, 3D. If all the things are considered, it is 4D. Okay, like 4 things means item, time, location, and supplier. Okay, so this was something about the data cube and multidimensional data model. Then we have scheme for multidimensional data model: star schema, snowflake schema, or fact constellation. Here they can ask it separately. In that, if they ask separately, you have to define in very depth each of means whatever they ask. Okay, if they ask in like all together what are the different schemas for the multidimensional data model, there you have to define these 3 schemas. Okay, and you have to define it briefly, giving an example. So here's a very repeated example which I can give you a brief information regarding that. Here is the 3 schemas: star schema, snowflake schema, and the fact constellation schema. So star schema, I'll directly jump into the example. It's like this. Okay, here there will be a fact table and there will be dimension table around it. There will be a fact table and there will be dimension table around it. So in the fact table, what you will store is the key value, which is the primary key. Primary key of this one is time key. Primary key of this one is branch key. Primary key of this one is location key, and the primary key of this one is item key. All the primary keys are getting stored here. Along with that, what are the facts, like how much the dollar sold and how much is the unit sold. So all these things will be stored in what? Fact table, and that is called as sales. And the remaining tables are time, branch, location, and what is that? Item. Okay. So after storing the primary key, regarding this, what are the extra information that will be storing here, and what are the regarding this branch will be storing here. Okay, like that will be storing here and here. So that's how the star schema is, because it's looking like a star, right? It has branches in the different directions, and this is in between. So that is a star schema. What about the next one, which is snowflake schema? It's just an extension of the previous one. Here we'll have an extension called as supplier and the city. So just for having a fact table, this all things is same. Copy paste this thing here. After that, you will be removing 2 things from here. See, these 2 things were present here. If you observe carefully in the previous one, supplier type, just the supplier type was mentioned. This just getting expanded. Okay, it's not actually mentioned here. Supplier type was just present here, it is getting expanded. Okay, so it got expanded here. Okay, it got expanded here. And what about the location? 3 things are here and the rest things are defined here. You just got to take one of these things like city as a city key, then you have to define the city key, province, or the country. Okay, so by just looking you can it looks like you can understand these things, but you got to make this table at least once. Okay, otherwise it will be in very hard in exam what you have to actually write here and here, what will be the connection, where will be the connection. Every small thing will matter when you sit for writing exam. So make sure you practice this, very important question from exam point of view. The last one is the constellation schema. In fact constellation schema, the same thing will be there as in the previous one. So I'll mark what was same. This was same in the first, second, and third schema. Just the difference is that the sales table's cousin brother will come. Okay, this is the cousin brother of sales table. So sales table is a cousin brother is shipping. Okay, So these both will be as fact tables. So what happens is there is another fact table which is having the same keys, item key, time key, shipper key, and some other extra features here. So what are the extra features that is getting expanded here? Like for example, what are the features keys you have taken that your expansion is given here, and some of them overlap. Like for example, time key and the item key is both for this one and this one, right? As you can see, item is for this one and this one, time key is also for this one and this one. Also the location is here, and just the branches for this one. Okay, so some things overlap and some things are not overlapping, like this one is a new one just exclusive for the shipping table. So that's what new fact table will be there, multiple fact table will be there, some will overlap, some will not overlap, and basically yeah, that's it. Okay, that's about the fact constellation schema. The information regarding this will be same as what I had explained for this one, just that two will be in one schema. Okay, that is fact constellation schema. So basically that's all what you have tried, 3 examples and theory regarding it. Then we have the concept of hierarchy and measures. Let's take an example of date country as it's given here. Okay. So what is the role of concept hierarchies? So a concept hierarchies means this is the most general one, all. Then we have the countries here like the Canada and the USA. Then we have the states here. After the states we have the cities. This is what the hierarchy, and this whole thing is what concept. So it is called as concept hierarchy. So from the general to specific is one hierarchy, another one is from specific to general. Okay, so this example you can give street, city, state, country, or you can go in the reverse order as well, year, quarter, month, day, or year, week, day. Okay, if you go in the reverse order or in the straight order, both will be the same thing. Okay, so basically you have to explain this only, what is the hierarchy, different levels will be there. Okay, so the content is also there, you can go through it. Then we have typical OLAP operations, very important question from exam point of view. There are 4 OLAP operations, measures and the computation. So this also there, a question is there regarding this, but it's not that important, so I'll give you a brief overview. Okay, so if they ask the what is the different measures and the categorization and computation, if they ask what are the different data cube measure, so I think the question should have been there. Yeah, measures is the second part of this question, I didn't read that one. So basically you have to explain here what is distributive, algebraic and holistic. Okay, so distributive means what, for I'll give an example. By using the example only you have to write the same in the exam. So there are 50 people in the class. Okay, how many people are there? 50 people are there in the class, and all of those people's weight is calculated. Okay, weight is calculated and the mean is taken. So 50 people's weight is calculated and the mean is taken, and that is stored as x. Okay, so if you store it as x here, but if you divide the class into 2 parts, this average you will calculate and this average you will calculate and add it up, again you will get some answer. Let's store it as y. Obviously both the answers x and y will be same, right? So that is what distributive. The whole thing can be distributed and the separate means can be calculated, or the separate operations can be performed, any operations, and if they are together the sum of these both can be equal to this one, then it is called as distributive. Okay, algebraic means there will be some algebraic function whose value will not be equal at the end. Okay, and there will be a constant parameter which is the restricted value, like it will be at most m parameters. Okay, that's what algebraic is like. It can be average, sum, count, where the both sum and count are distributive aggregate functions. So both the distributive aggregate functions, if they divided with each other, that is called as algebraic. Any algebraic operation can be performed here, that's what you have to mention here. The last one is the holistic. In the holistic we don't have any parameters, there is no constant bound, same as algebraic function but there is no constant bound. Okay, that's what the main key point is, and the examples are also given, you can go through it. Then you have the last one which is the OLAP operations. 4 OLAP operations, very simple. I will give you the brief information how you need to write 4 OLAP operations. Remember this: roll up, drill down, slice and dice, pivot or rotate. Roll up, drill down, slice and dice, pivot or rotate. Okay, so what is roll up? Roll up means when you wear a shirt, full sleeve shirt, to when it is very hot outside, what you will do, you will roll up your sleeves, right? So rolling up is like that only in the cube as well. Okay, so if you have a bigger cube here like this, if you roll up, what will happen, it will just show all these months as quarter 1, quarter 2, quarter 3 and quarter 4. That is called as roll up. Other information is given here, like as you can observe here, this is the main cube. Okay, in the main cube you have Vancouver, Toronto, New York and Chicago. These are the cities present. If you roll up the cities, it will become countries, right? So what happens is Toronto and Vancouver will become Canada, and Chicago and New York will become USA. So whatever was in the numeric values, these two will be added and written in the with respect to Canada, and whatever was here, that will get added and written with respect to USA. Okay, that is the roll up. and the next one is the drill down. Drill down means you will be expanding. Just observe that, like this is the cube here and you got angry with the cube and you just pulled it down like this. Okay, so it got pulled down and you got here many different things like the whole month's information. So quarter 1 was given as 605. It consists of 3 months, January, February and March, but you want to know what actually happened in January, what actually happened in February and what actually happened in March. So what you did is drill down operation. So in drill down operation, each of these individual value you will get to know. Okay, the more zoomed value, like in quarter 1 all were together, this sum was stored here, but when you drilled it down you got to know what actually happened in each of these month. That is known as the drill down operation. Then we have slice and dice. What is slice and dice? Slice means the horizontal cut, dice means the vertical cut. Okay, so if you do slice and dice, what will happen? It will become a small cube, right? So I'm just interested in seeing what happened in quarter 1 and quarter 2 for Toronto and Vancouver. So I need not require the whole cube, right? So what I will do is, this is the main cube, right? So I'll slice it in this way and dice it in this way. I told in reverse order, this is slice and this is dice. Okay, so anyway, got the point, right? If I slice and dice, and I'll do the slice and dice here as well. So if I do that, I'll just be remaining with this small cube. That is what slice and dice is. Okay, then we have the last one, which is the pivot or rotate. Pivot or rotate means if you want to see the same thing in different dimensions, at that time we will do the pivot operation. Okay, so see here, there is locations present here and the items are present here. If I do the rotation operation with respect to the items, the locations will come here, the items will come here. Just seeing the same thing through a different perspective is called as rotate. Okay, it was pivot and rotate. Okay, yeah, pivot and rotate. Okay, so the further information regarding this can be found here. You can go through it to get the key points what you have to write, and that's all basically what is there in the module 1. And if you like this video, hit the like button and don't forget to subscribe to my channel. And if you have got any doubt, ping me in Instagram. My ID is in the description box. And thank you so much for watching. I will see you in the next video.